Imagine if, overnight, every human being shrank to the size of an ant, roughly 2 to 3 millimeters tall, and our entire world transformed into an overwhelmingly hostile environment. How would we adapt our approach to survival in a reality where conventional infrastructure such as buildings, transportation systems, and utilities are rendered useless, forcing us to reinvent shelter, energy generation, and communication methods on a microscopic scale? In such a scenario, traditional food and water sourcing would be upended, demanding entirely new strategies for nutrition and hydration, while the collapse of established social, economic, and governmental systems would necessitate the formation of localized communities with radically different social orders. What innovative technologies, healthcare practices, and adaptive behaviors might emerge in response to the heightened risks of injuries, infections, and environmental hazards, and how could this dramatic downsizing ultimately reshape not only human civilization but also our interaction with and impact on the natural world? If all humans were to shrink to the size of ants overnight, the consequences would be profound and far-reaching, reshaping every aspect of our lives. Here are some changes and challenges we would face in this dramatic scenario. A hostile physical environment. At the size of ants, roughly 2 to 3 millimeters tall, the world would become a treacherous place. Everyday objects would transform into colossal obstacles. A chair would be as tall as a skyscraper, which would be too much work to climb or walk around. A puddle would be a huge lake, which would drown us if we fell into it. Small animals would turn into towering threats. Insects like ants, already absurdly powerful for their size, would overpower us. Spiders, beetles, or even mites would be killer monsters, where survival would always be a matter of struggling with what were once trivial pests. Useless infrastructure. Our current infrastructure would be rendered obsolete. Homes, offices, and cities would be unbearably huge to inhabit or maintain. We'd need to leave them behind and take shelter in smaller, more manageable spaces, like cracks on the ground or hollowed-out plants. Cars, planes, and roads would be useless. We might be able to evolve by taming insects, like riding on beetles, or constructing microscopic transports from naturally occurring materials, but this would require entirely different engineering tactics. Power lines, pipes, and heating systems would be inaccessible, and we would need to find new ways of generating power or staying warm, maybe on a microscopic scale. Food and water challenges. Sustaining ourselves would mean a complete overhaul of how we get our sustenance. Large-scale agriculture would be impossible. We might subsist on hunting bugs, scrounging micro-life, or cultivating small plants such as fungi or moss. Our cuisine culture would be revolutionized to whatever is available at our scale. Dew droplets, condensation, or small puddles might be where we get our water. Yet we'd have to be careful. Surface tension at this level would keep us inside a drop, so getting hydrated would be a risky endeavor. Collapse of social structures. The systems that define human society would break down. These are based on human-scale relations and resources. With everyone miniaturized, international trade, money, and government would fall apart, compelling us to establish small, localized communities centered on short-term survival. We'd need to establish new hierarchies and rules befitting our diminutive size, perhaps after the colonies of ants with communal work and shared purposes. Technological setbacks and innovations. Our current technology would be impractical. Factories, telephones and computers would be too large to operate. Electricity in the way we utilize it might be impossible to generate or tap. We'd have to invent technologies suited to our size. Think nanotechnology, microscopic mechanical devices, or bioengineering using microbes. For example, we might use bacteria to produce energy or materials. Communication difficulties. Staying in contact would be difficult. Our high-pitched, thin voices wouldn't carry far. Long-distance communications like telephones or radios would be impossible using today's technology. We might employ other methods, like vibrations tapping messages along surfaces, or chemical signals releasing scents like ants do, but these would take time to develop and master. Health and medical vulnerabilities. Our tiny bodies would face new risks. Falling from a short distance, like the top of a table, could be fatal, and cuts or infections would be harder to treat without smaller medical equipment. Bacteria and viruses, now relatively larger compared to us, could be more lethal. We'd need to pioneer microscopic medicine, perhaps using natural compounds or tiny organisms as treatments. Environmental impact. One silver lining would be our reduced ecological footprint. We'd consume far fewer resources, think crumbs instead of crops, and produce minimal waste. This could allow ecosystems to recover from human-induced damage like deforestation or pollution, though we'd no longer be in a position to actively manage or repair them. Lane conclusion: if, one night, humans were miniaturized to the size of ants, we would have a world of enormous problems, an unfriendly environment, redundant infrastructure, scarce resources, and societal collapse. We would survive based on our ability to adapt, reconceptualizing food, shelter, communication, and technology on a microscopic scale. While our resilience and ingenuity would be tested like never before, our diminished size might also give the planet a chance to heal. It would be a radical, humbling reset for humanity.